Hi, folks. In this section, we're going to learn how to factor polynomials of the form ax squared plus bx plus c. Last time, we learned how to factor these polynomials where the leading coefficient was 1. This time, the leading coefficient is something other than 1. So we're going to learn a few different ways to handle this. And so let's look at the first possible method. The first strategy to use, just because it's the easiest, is to look for a greatest common factor and to try to factor it out. So for instance, 5x squared plus 15x plus 10. Here I have a leading coefficient of 5. And so this fits the example where there's something other than 1 as our leading coefficient. But it turns out that this does not need to be handled, especially using the methods that we look at below, because the 5 is a common multiple of a, b, and c, and we can factor it out. So if I factor out that 5, kind of doing the reverse distributive property, 5x squared divided by the 5 leaves us with x squared. If I take the 15x and divide it by 5, I'm left with 3x. And if I have 10 and I divide it by 5, that leaves me with 2. So what I have now is a polynomial with a leading coefficient of 1, just like we learned last lesson. And I can factorize this using the same strategies that we used last lesson. The factors of C are 1 and 2, and of course 1 plus 2 equals 3. So this is very straightforward to factor now. X plus 2 times x plus 1. And don't lose that 5. That 5 is an important factor of this entire polynomial. So if you can factor out a greatest common factor so that either all of your factors are just smaller or you actually get a leading coefficient of 1 here, that will make your life a lot simpler in terms of factoring. What happens if that's not possible? What if there is no shared common factor here, like 4, 13, and 3 do not have a greatest common factor other than 1. Then we have to employ the strategies of dealing with polynomial with this leading coefficient here. The way you approach these problems is by looking at the possible factors of A, looking at the possible factors of C, determining the possible factorization to figure out what the middle term would be. Let me show you what I mean. The possible factors of A, the different ways to get 4, I could either have 1 and 4, or I could use 2 and 2 as my factors. Now, as it turns out, I'm going to need to list 1 and 4 twice, because when I do my factors of C, and the factors of 3 are just 1 and 3, I can list these in 2 possible orders. I can either go in the order 1, 3, or I could go in the order 3, 1. So you need to list the factors of A repeatedly to compensate for the fact that you could write your factors of C in different orders. I do recommend being consistent about this. A tends to be a smaller number than C, so it has fewer factors. And just being always consistent about how you write those factors of A down, always be consistent about the same order and only flip C. You certainly don't want to flip both, because then you'll end up pairing the same factors together. Because what I'm going to do for this possible factorization is I'm going to group the 1 with the 1. So that's going to be 1x plus 1. Of course, normally we wouldn't write the 1 there. So I'll go ahead and erase it. X plus 1. And then my second set of factors would be the 4 with the 3. So 4x plus 3. That's the possible factorization here. Whereas for the second example, I would have 1 with the 3, so x plus 3, and then I would group the 4 with the 1 for x plus 1. So those are both possible factorizations. When I listed 2, 2, I did not need to list 2, 2 twice because 2 is a repeat number. So it doesn't really matter if I write my factors in the factors of C in the order 1, 3 or 3, 1, because each time they're being grouped with the coefficient 2 in front of the x. So I can write this as 2x plus 1 times 2x plus 3. Those are all of my possible factorizations. But what matters is which possible factorization gives me the correct middle term of 13. So to think about the middle term, when we think about FOIL, the middle term comes from doing the outer terms together and the inner terms together. So that's what I'm going to focus on here. I'm going to focus on the outer terms and the inner terms. So what's 3 times x? 3 times x is just 3x. Then what's 4x times 1? Well, that's just 4x. So what would my middle term be with this possible factorization? It would be 7x. Let's do the next example. Outer terms, 3x times 1 is just x, and then 3 times 4x is 12x, and x plus 12x is 13x. I have just found the correct set of factors here. And so I can stop at this point for the sake of completeness because we're just learning how to do this. I'll go ahead and show you what we have here. First term times last term, 2x times 3 is 6x, and 1 times 2x is just 2x. So we have 8x here. Unlike last time, last topic where it was a little more predictable to know when you were going to get really big numbers and really small numbers. These types of problems take a bit more practice to spot how you get really big numbers. The general idea here is that if you put a big number in the first set of parentheses and a big number in the second set of parentheses, then you can end up with a bigger middle term overall. If you have both of the big terms in the same set of parentheses, they never multiply times each other. So you tend to get smaller values. Now that I've found the correct set of factors for my problem, I should write them separately. X plus 3 times 4x plus 1. And of course, you can do the FOIL method to check your answer to make sure that it checks out. X times 4x is 4x squared. 3 times 1 is 3 for the end. And then my middle terms, I've got x plus 12x, which is 13x, and that does check out. Notice that because my C term was positive and my B term was positive, I knew that both my factors were positive. This part is similar to what we learned last class, and so we'll use that same approach as we move down here and factor a polynomial where C is positive but B is negative. And because of this, both my factors are going to need to be negative. So if I think about the possible factors of A, I could have 1 with 3. Just like before, I'm going to need to list that twice because I'm going to have factors of C. I could have 1 with 2, or I could have 2 with 1. So I could go in the order 1, 2, or I could go in the order 2, 1. Remember, all of these factors of C have to be negative because when I add up my middle terms, they need to have negative signs so that my B value can be negative overall. So my possible factorizations, I could have x minus 1 times 3x minus 2. I'm just going in the order that I have them written here. This factor goes with this factor. This factor goes with this factor. Or I could write this as x minus 2 times 3x minus 1. The question is which gives me the correct b term in the middle. Remember to focus on the outside terms and then the inside terms. So x times negative 2 is negative 2x. And then the inside terms, negative 1 times 3x is negative 3x. And that adds up to negative 5x. That's not the correct middle term. So this last one must be correct. X times negative 1 is negative x, and then negative 2 times 3x is negative 6x, and that adds up to negative 7x. And that does check out. That's the set of factors that I want to use. Okay, let's look at an example where b is negative and where c is also negative. If we can, with all of these steps, if you can factor out the greatest common factor, do that first. It will make your life easier because with smaller numbers, smaller values, there are less factors to think about. But for A here, we can have the factors 1 and 2. For the number negative 7 here, to get negative 7, one of my factors has to be positive, one of them has to be negative. So I could use the factors 1 and negative 7, but I could also put the negative first. I could say negative 1 and positive 7. So I need to kind of repeat my factors of A again. Not only that, I could change the order in which I write the 7 and in which I write the 1. So I could write 7 with negative 1, or I could write negative 7 with positive 1. So I need to write my factors of A even more times. Even though 2 only has 2 possible factors, even though 7 only has, or negative 7 has 2 possible factors, there are 4 possible combinations of factors to test here. So when you have a C value that's negative, when A is still positive, we're going to treat it differently when A is negative. We'll do an example of that in a little bit. But when C is negative, you need to test a lot of different combinations of factor values. So let's look at those possible factorizations. If we've got a coefficient of 1 on our x, and then we add 1, and then we have 2x, and we subtract 7. That's what all of those factors mean there. For example 2 here, we have x minus 1 with 2x plus 7. When we have this third set, we have x plus 7 times 2x minus 1. And when we have x minus 7, we have 2x plus 1. So those are all of our possible factorizations. Let's look at our middle terms. For our middle terms, we look at the outside terms and then the inside. Outside is x times negative 7, which is negative 7x. Our inside terms are 2x times 1, so that's positive 2x, and that adds up to negative 5x. As it turns out, that is the correct answer here. We do not need to move on and test the others. But just for practice, you can go ahead and pause the video and fill out the others and see what you get. Negative 2x plus 7x is 5x. 14x minus x is 13x. and negative 14x plus x is negative 13x. I wanted to finish the table here so that we could look for patterns so that in future we maybe don't have to test quite so many combinations of factors. Again, notice that when the big numbers are in different sets of parentheses, like here, this big number 7 is in a different set of parentheses than this big number 2. 2 is big compared to the one that I have over here, and 7 is big compared to the one that I have over here. So that's what I mean by putting the big numbers in different sets of parentheses. That's what results in a larger absolute value of b. We get a smaller absolute value of b if we keep all of our bigger numbers in the same set of parentheses because they never multiply each other. Another thing to think about is where that negative number is. This is a little more complicated than it was in the previous section. It doesn't quite always work where if you just put the negative number on the bigger number, then b is definitely negative. If you put the negative number on the smaller number, then b is definitely positive. It doesn't quite work that way, although, or it doesn't always work that way, but it did in this example here. So just writing down our final answer, x plus 1, the quantity, times the quantity 2x minus 7 is our correct factorization for this problem. All right. What do we do when there is a negative sign on A? How do we handle that? The best way to handle this is to treat that -1 as a part of the greatest common factor or as the greatest common factor. So I'm going to rewrite this as kind of like a distributive property thing here, reversing the distributive property. Take out the -1, so I'm left with 4x squared plus 8x minus 5. Notice that I flipped the sign on every single term inside the polynomial because of that pulling the -1 outside the parentheses. So when I factor this polynomial, I'm going to focus on the 4x squared plus 8x minus 5. And then in the end, I will have -1. Need to remember to put the -1 outside the parentheses. So what are my possible factors of A? Well, I could have 1 with 4. I'm going to end up needing to write this a few times like we did with the first example. And then I could have 2 with 2. The reason I'm having to write this so many times is because I have a negative sign on my C value. So one of my factors is going to be positive. One of my factors of C is going to be positive and one is going to be negative. And the only way I can get, and so I'm going to have a bunch of factors to test because which number comes first, which number comes second, as well as which number is positive, which number is negative. We have all of those different combinations to test. What are my factors of 5? They could be 1 and 5, and let's start with the 5 being negative. And then you could have -1 and 5, where the 5 is positive this time. Next, we could change the order of that. The 5 could come first. Again, we could, this time we'll do 5 with -1. And then we can switch the signs and we can start with -5 and +1. When we have uh, 2 and 2 as my factors of A, we don't have so many combinations to test because if I write 1 and -5, the 1 is with a 2 and the -5 is with a 2. The order doesn't matter this time, but I still need to change the sign. I still need to also test -1 and +5. So what are our possible factorizations here? I could have x plus 1 times 4x minus 5, x minus 1 times 4x plus 5. I could have x plus 5 times 4x minus 1, x minus 5 times 4x plus 1, 2x plus 1 times 2x minus 5, and 2x minus 1 times 2x plus 5. So those are all the possible factorizations that we have to consider. And now we need to look at what the middle term is by focusing on the first multiplied by the last, the outsides, as well as the insides, the second multiplied by the third. So what do we have here? This is 4x minus 5x, which gives us negative 1x. Here we have negative 4x plus 5x, and that gives us positive 1x. Oops, I forgot to write my x there. Here I have 20x minus 1x is 19x, and negative 20x plus 1x equals negative 19x. Notice, and this is a good strategy, if I keep the numbers in the same order but change where my negative sign is, my middle term ends up having the same value with just a different sign. So that can make it a little faster to fill out this part of the table as we go, because notice I'm going x, x, 19x, negative 19x. So the last two examples here, I've got negative 10x plus 2x is negative 8x, and 10x minus 2x equals positive 8x. I finally got that value that I needed. It was the very, very last one in my list of 6. That's pretty frustrating. We'll talk about a shortcut in just a moment and how that shortcut can help you. But first, let's write down our final answer here. We have that negative 1 that we factored out to begin with times 2x minus 1 times 2x plus 5. And as always, you should check your results using FOIL. 2x times 2x is 4x squared. 2x times 5 is 10x. 2x times negative 1 is negative 2x. And negative 1 times 5 is negative 5. And that does check out. So yes, that works. That is our correct final answer. Okay, so how can I make this list shorter? Because this list got kind of crazy long. What can I do to make this easier? This method here is called the AC method. And it's called the AC method because we're going to focus on A and we're going to focus on C. What I'm going to do is multiply those numbers together. So I've got 4 and negative 5, and I'm going to just do 4 times negative 5 is negative 20. And I'm going to find factor pairs of negative 20. I'm going to list the factors of 20. I'm not even going to focus on the negatives right now. I'm just focused on the integers. So I could have 1 times 20. I could have 2 times 10, 3 doesn't work, 4 works, 4 times 5. And now my numbers are approximately equal, so I can't come up with any more factors. So what I want to do is I want to look at these factor pairs and I want to choose the factor pair where when I subtract the numbers from each other, I get the B value. Now, the strategy here is if AC is positive, I choose factors that add up to B. But if AC is negative, I choose factors that subtract to B. And here I see that 10 minus 2 is 8. And so I'm going to focus on this set of factors here. So let me focus on that set of factors, 2 and 10. What I want to do now is I want to further factor this so that I have numbers, 2 of my numbers multiplied to give me A, and 2 of my numbers multiplied to give me C. So 2 can't even really factor anymore any other way than just 1 times 2. But I've got some choices for 10. 10 could be 1 and 10. It could be 2 and 5. And what I find is that 2 and 5 are the numbers I'm looking for because 2 times 2 gives me 4, which is my A value. And then 1 times 5 gives me 5, which is negative 5 is my C value. Oh, I'm underlining the wrong thing. 4 and negative 5. So these right here are the 4 factors that I'm looking for. I know that I want to get my A value by multiplying 2 times 2. So automatically, I never had to test those 4 possible combinations because it's the wrong factors of A. Of course, 1 and 5 really are the only factors of 5, so those ones work. But I would have limited myself to just testing those 2 values using this AC method. It takes some practice to get used to, but this is a way of kind of just narrowing down the field of possible factors that you need to test. All right, let's do a real life problem. Finding the area of a rectangle. We are told that the length of a rectangle is 1 mile longer than twice the width. Okay, this is the width of my rectangle, and I need to be 1 mile longer than twice the width. So twice the width plus 1 more. So those are the dimensions of my rectangle, and I know that the area of the reserve is 55 square miles. So I want to know what is the width. Okay. Um, well, I know that the area of a rectangle is length times width. So I can do area is length times width. My length is 2w plus 1. My width is just w. And my total area is going to be 55. I'm going to need to kind of combine this all into one polynomial set equal to 0 so that I can use the 0 multiplication property to calculate my possible solutions. So first, I need to distribute this problem, this w to everything in parentheses. So if I multiply everything here, I end up with 2w squared plus w equals 55. But I want to set this polynomial equal to 0. So I'm going to subtract 55 from both sides of the equation. And I'm going to get 0 equals 2w squared plus w minus 55. I am going to go ahead and use my AC method to kind of target what uh, values to test here because I don't want to test all of the possible factors here and all the possible combinations. So what I'm going to do is I'm going to do 2 times 55. I'm going to get that value, which is 110. And I'm going to think about the factors of 110. I could multiply 1 times 110. I could multiply 2 times 55. I could do 5 times 22, or I could do 10 times 11. Those are kind of the possible combinations here. And because my A times C is negative, I want to choose the factors where when I subtract them from each other, I get that center term. I get that positive 1, my B value for that center term. And the only factors that I have are 1 apart are these, the 10 and the 11. So what I'm going to do now is I'm going to take those values and I'm going to split them apart into their factors so that I have 4 factors, 2 that are factors of A and 2 that are factors of C. So 11 is prime. Its only factors are 1 and 11. And 10 has 2 factors, or has more than those factors. It could be 1 times 10, it could be 2 times 5, but I can see here from that 55, I need to have a 5 in here for sure. So 2 times 5 look like the right factors to test here. And then I see that to get a 2, I would use my 1 times 2. And then to get to my 55, I would do 5 times 11. So I can narrow down the table of values that I choose. My factors of A are going to be 1 and 2. I'm still going to have 4 things to test because even though I know my factors of 55 are 5 and 11, this is negative 55 that I'm aiming for. One of them's positive and one of them's negative. So I'm going to have negative 5 times 11, or uh, 5 times negative 11, or I can just change up the order now. I can have 11 with negative 5, or I can have negative 11 with positive 5. Those are all the possible combinations. Now, with practice, you may find that you're more likely to find some things work over others. So you may find ways to kind of narrow this down so that you don't actually have to write out all the possible factorizations. Here, this would be represented by x minus 5 times 2x plus 11. This would be x plus 5 times 2x minus 11. Here we would have x plus 11 times 2x minus 5, and then we would have x minus 11 times 2x plus 5. So with this possible factorization, we can do check for our middle term. Here we have as our middle term, we would have 11 times x, which is 11x, minus the 10x, which gives us 1x. And I just realized that the original equation used w's instead of x's. It doesn't really matter. But here I've happened on the right answer right away, so I don't have to test anything else. Because, though, did I didn't change the order of the numbers. I just changed the order of where the sign was. I don't really have to do this calculation. I can just know that it's the opposite of what I calculated for the previous one, the opposite sign. But this one checks out. So I know that this gets factored in this way. 0 equals x minus 5 times 2x plus 11. At this point, we aren't quite done with the problem because we are asked what is the width of the reserve. So what we need to do is set each portion of this multiplication problem equal to 0 to find out what the possible values of x are, or in this case, w, since that's what the original equation asked for. So either w minus 5 equals 0, or 2w plus 11 equals 0. In this case, if I add 5 to both sides of the equation, I get w equals 5. If I work on this version of the equation, I subtract 11 from both sides, and I get 2w equals negative 11. Divide both sides by 2, and I get w equals negative 11 halves. Of course, it doesn't make sense to have a negative width. Distance has to be measured with a positive number. So that value doesn't make sense, but the number 5 does make sense. And we've just discovered that the width of the reserve is, in fact, 5 miles long. So this is how you factor polynomials where you have a leading coefficient in front of the x squared term. I hope this helped.